In this video, we're going to go through overall polarity. Our essential question is, how do bond polarity and molecular geometry work together to determine whether a molecule is polar or nonpolar? All right, since we're talking about polarity and polar nonpolar, maybe we should define the word polarity. Well, polarity is a property of a molecule where there is an uneven distribution of electron density, which causes one part of the molecule to have a partial positive charge and another part to have a partial negative charge. So you've heard the word polar before, and you've probably heard it with the north and south poles of the Earth. So the magnetic field has different properties depending on if you're on the northern part of the globe or the southern part of the globe. We also talk about polarity in electrical circuits, specifically batteries. So if we have a battery here, you've got a positive end and a negative end. There are poles to our battery. So just like magnetic fields and with electrical circuits, we have polarity on molecules. So a nonpolar molecule has an even distribution of electron density. Okay, this is going to be really important. Everything is evenly distributed. So in a nonpolar molecule, every atom attached to the central atom is going to be the same. There aren't going to be any lone pair of electrons on the central atom. So I'm going to represent this with just some variables here. So let's do X and Y. Okay, now, if you think about this in terms of a force diagram from physics, all of the bonds between atoms Y and X are the same. So that would be like a force diagram where all of our force vectors are pulling in opposite directions and they're pulling with the same amount of force. They're going to all cancel each other out. So one side isn't going to be stronger than the other. They're all going to cancel each other out. That's essentially how a nonpolar molecule works. Now, a polar molecule has an uneven distribution of electron density. So to identify a polar molecule, not every atom attached to the central atom is the same. And you're also going to see, in some cases, lone pair of electrons present on the central atom. So if you have one of these conditions, you are a polar molecule. So again, let's represent this with some variables. And think about it in terms of a force diagram. So let's say all of our Y's are pulling with a certain amount of force, but then you have Z, which is pulling with a lot more force. Well, yeah, the X and Y's are going to cancel each other out because they have the same amount of force. They're pulling with the same amount of force. And then in the Y direction, you've got a lot more force pulling up than you do down. So here you're going to have a polar molecule. One side is going to have more electrons than the other. Now you can also have a polar molecule if you have lone pair of electrons. So those lone pair of electrons cause a shift in electron density. So if you have these, those also make your molecule polar. Remember, polarity has to do with the distribution of electrons. So if you have lone pair, they are going to cause an uneven distribution of electrons. So I know in this case it kind of looks like they're canceling each other out, but this is going to cause the molecule to be polar. All right, so we're going to go through a couple of examples. We're going to be drawing Lewis structures and then determining the overall polarity of the molecule. So whenever we do Lewis structures, we always start by listing out the number of valence electrons. So for hydrogen, there's one valence electron, but there's two of them in this case. And then oxygen has 6. So that'll be 8 total. The central atom is always the singular atom. And then we're going to bond everything with a single bond. Each single bond is 2 electrons. So 2, 4. I have 4 left. Remember, hydrogen wants 2 to be happy. Oxygen's going to want 8. Oxygen only has 4. So let's throw in those electrons on our central atom. Okay, now let's go through our rules. So, is every atom attached to the central atom the same? Yes, but we have lone pair of electrons on our central atom, so this is going to be a polar molecule. All right, let's do this one. So CH4. So carbon is 4, hydrogen is 1, but there's 4 of them. That means that we have 8 total. Carbon goes in the middle. Hydrogen goes all the way around. I'm going to single bond everything. 2, 4, 6, 8. Okay, now let's just quickly check. So every hydrogen has 2, and they want 2. Carbon has 2, 4, 6, 8. It's happy. So now we move on and take a look at everything. Every single atom attached to the central atom is the same. We don't have any lone pair of electrons here, so this is going to be nonpolar. All right, let's move on to NH3. So nitrogen has 5, hydrogen has 1, but there's 3 of them. So if I add those up, that gives me 8. Nitrogen is going to be our central atom because it's by itself. I'm going to surround it with hydrogens. Single bond everything. 2, 4, 6. Okay, so I have 2 left. All the hydrogens are happy because they all have 2. Let's put those last 2 electrons on our central atom. We are good. Okay, everything attached to nitrogen is the same, but we have a lone pair of electrons here. So that makes our molecule polar. Okay, next one we have PCl3. Okay, so if we look at phosphorus on the periodic table, phosphorus has 5, chlorine has 7, but there's 3 of them. 5 and 21 is 26. Phosphorus is going to go in the middle because it is our singular atom. Single bond everything. 2, 4, 6. Okay. I'm going to give each chlorine 6 because they all want 8 and they currently have 2 from that single bond. So let's go around and give everybody 6. 6 times 3 is 18. We did it 3 times, so that gives me 2 left. Phosphorus wants 8. It has 2, 4, 6. So to get to 8, let's put those last 2 on there. All right. Now, every atom attached to the central atom is the same, but just like the last problem, we have a set of lone pair on the central atom, so this one is going to be polar. All right, draw the Lewis structure and determine the overall polarity of the molecule. This time we have C2H6, so carbon, hydrogen. Carbon is 4, there's 2 of them, that's 8. And then we have hydrogen, there's each one of those is 1. We have 6 of those, so that makes 6. 8 plus 6 is 14. Now, we have 2 carbons, so both carbons are going to go in the middle, and we're going to surround everything with hydrogen. Single bond everything. 2, 4, 6, 8, 10, 12, 14. every single atom here is attached, or every single atom that is attached to our central atoms is the same. So this is going to be nonpolar. All right, so those are a couple of examples, and we went through some definitions, and that is how you determine overall polarity.